Today I'm going to bake this chocolate cake. Now those of you who know me know that the only reason I would do this is to prove a point. Earlier I was asking people to compare the temperatures of these two objects, a science book written by Isaac Asimov and an old metal hard drive. Can you compare their temperatures?
I'd say this one would be
Yeah,
colder.
that feels
Metal.
colder.
Cold and nice room temperature.
Can
You
tell
would
me?
say colder than that one.
Yeah. What makes something hotter or colder? What affects that?
The actual material. I mean, paper is warm and metal is cold.
Both of these objects have been sitting here on the ground for quite a while, so one might expect that they're at the same temperature.
No, because this is a metal and that's paper.
But what if I left that outside all day? Would it be 15 degrees?
No, because paper doesn't absorb cold.
Doesn't absorb cold.
No.
Well, I've left books out not all day, outdoors, and I can't say that I've noticed the book was cold when I've come to pick it up. Ever.
What if I told you that these two objects are actually the same temperature? What would you say?
Definitely not. If you take a temperature right now, this is colder.
So let's say you're taking a cake out of the oven.
Yeah.
Would you be worried about touching the cake?
Yes. Well, not the cake itself, but the actual tin around the cake, because it'll be hot.
Yeah, but how does the temperature of the tin compare to the temperature of the cake?
Well, the cake will be warm, like hot, but not as hot as a tin.
The tin's hotter because it's metal. Metal holds the heat longer and holds the cold longer.
Like if
You
you,
don't
touch
think the tin would be the same temperature as the cake?
well, you think if it's been like in 200 degrees Celsius oven, it'd be the same, but it just doesn't feel like it will burn with metal, whereas my fingers will burn. But I mean, not if I stick my finger in the cake, it wouldn't burn as much.
All right, it's time to take the cake out and find out if it's the same temperature as the tin. I have a meat thermometer with which to measure the temperature of the cake. I'm not sure that's the most accurate way of doing it, but, well, it's the only thing I've got. So let's give it a shot. So I tried to measure the temperature of the cake using a meat thermometer, but unfortunately its temperature scale doesn't go high enough to allow me to accurately measure the temperature of the cake. You can actually hear the moment when I realized that my experiment wasn't going to work. Uh-oh. So now I'm back in Vancouver, and I thought I'd bring in the big guns to help me sort out this experiment. And by the big guns, I of course mean my mom.
So, Derek, I understand we're going to make this vanilla cake mix together and see what happens.
We've got a secret weapon, which is this infrared thermometer, which can measure temperatures up to 300 degrees Celsius, so we should have no problems with it. We just point it at a surface, and it gives us a readout of the temperature of that surface. So this should be perfect for measuring the temperature of the cake and the tin. Do you want to make a prediction about the relative temperatures of the cake and the tin when we bring it out of the oven?
Well, I really suspect that the tin's going to be a lot hotter than the cake. You can really not handle the tin at all. So I reckon that's what's going to happen.
Okay. Well, I think they're both going to be the same temperature, but I could be wrong. So we're going to have to do the experiment and find out.
All right, let's get mixing.
Okay, so it's been about a half an hour, and the cake is cooked. It's ready to come out.
Yeah, we're all ready to go.
That is your expert opinion as the master baker here?
Yes, I think so.
Okay, we're going to take the cake out of the oven, and we're going to check the temperature of the tin and the cake. Let's do it.
Okay.
Ooh, it looks like a good cake.
Yeah, not a bad one.
Okay, so let's measure the temperature of the cake. We have.
108.9.
And the temperature of the tin.
118.6, but dropping.
Over here.
108.1.
So we have, what would you say about the temperature of the cake and the tin?
Pretty close. Much closer than I expected.
They're quite similar. They're both around 110
Yes.
Celsius. That's my point, is that the tin and the cake are the same temperature. But the tin is going to conduct heat to your hand much faster than the cake. So the
Oh,
tin
I
would
see.
burn you, but the cake would not. But they're the
Okay.
same temperature. What if I were to impress upon you that they are in fact the same temperature?
I'll take your word for it.
And that in fact that these two are the same temperature?
No, I don't agree with that.
You don't think those are the same temperature?
No.
Really? I just can't believe this book is 15 degrees. It just doesn't feel it. I just
I know, it
can't
doesn't-
believe it.
In truth, there's no difference in the temperature between these two objects. If they've been in the same surroundings for a long period of time, they come to thermal equilibrium with their surroundings, which means they're both at the same temperature. But the metal feels colder because it's able to conduct heat away from my hand faster than the book. So just because an object feels colder that doesn't mean that it actually has a lower temperature. It may just mean that it's conducting heat away from your hand faster.
I see. Well, it's interesting.
Isn't it weird?
I've just learned something.